All right, so here are the solutions to the problem set that was due last night. If you haven't completed this, please do so as soon as possible and submit it. Hopefully this helps with some of the questions that I've been getting. And yeah, please reach out if you still have any remaining after watching this about the problem set. So looking at number one, we need to prove this identity. And in order to do that, what we first want to do is identify the side that's more complicated, because remember, to prove an identity, you need to simplify one side to make it look like the other side. So we're going to simplify this complicated side over on the left here. So the first step, there's actually a couple different things you can do, but the first step we can do is either turn everything into sine and cosine, or we can look for the Pythagorean identities. So the Pythagorean identities, I'm going to write them over on the side here. I didn't copy and paste it here, but it's sine squared theta plus cos squared theta equals 1. Then we have 1 plus cotangent squared theta equals cosecant squared theta. And then we have tangent squared theta plus 1 equals secant squared theta. Now those are given to you, those are on your formula sheet. You don't have to memorize them necessarily. You can if you want, it's not a big deal if you don't. All right, so looking right here, what I have is I don't have an identity for the top of this. 1 plus secant is not an identity. If I try to move sine, the 1 over to this side, that's not going to work. I have secant squared minus 1, but not plus 1. So that is not an identity. But if you look at the bottom, 1 plus tangent squared is an identity. Okay, it's right there. 1 plus tangent squared is secant squared. So the first thing I can do is just turn that 1 plus secant squared x, and then just put that over secant squared x. So we can turn 1 plus tangent squared into secant squared. Now, some of you guys got stuck here, some of you guys didn't. There's a couple different ways of going about this. There's an easier way and a harder way. You could take everything and put it over, make it into sine and cos. Another way to do this is you're allowed to split those up. So you can take this and you can write 1 over secant squared x plus secant squared x over secant squared x. Well, 1 over secant squared x is cosine squared x, right? That's the reciprocal identity, plus 1. And if you notice at this point, those are the same. Okay? If you turned everything into sine and cos, and then made a common denominator, you could cancel it. You would get the same solution that way as well. All right, moving on to number 2. Now, there was a typo here. I did post in a bunch of different places. This should say equals negative 1. So if you were confused and you were like, why the heck am I just getting negative 1 when it should say negative 1? That was my fault. Okay, this should say equals negative 1. So the more complicated side that we're going to have to simplify is this one. So first thing we're going to do is factor. So what factors out? Cosecant squared a. And what's left is cosine squared a minus 1. Now, cosine squared a minus 1 is an identity. Okay, if we look over here, we have this top one here. Now, you might be like, wait, but if I subtract 1, I'm still going to have a sign on this side, and that is true. So if I have, let's rewrite this. If I want cosine squared a minus 1, I need to subtract the 1 over. But then I'm going to have nothing on the other side. So I also need to move sine squared theta over here. So what I end up with is cosine squared theta equals minus 1 equals negative sine squared theta. So rearranging this, cosine squared theta minus 1 is actually negative sine squared theta. So let's write that over. Okay, Last step, turn everything into sine and cosine and see what cancels. So this is 1 over sine squared a. This is negative sine squared a over 1. And you probably noticed these cancel. All that's left is a negative 1, which is what we wanted here. So there are the solutions. Again, if you have not answered this yet, now is the time to get this finished and turn it in so you get some credit for it. And reach out if you have any questions. I will be posting the next lesson video on Monday. Have a nice weekend. Bye.